Last lesson, we alluded to the fact that monomials have missing parts, for example, coefficients and exponents. For example, if we just had x, what would we say the coefficient and the exponent for that variable is? Now, we would basically say no coefficient and no exponent, right? But in fact, there is a coefficient there that we can't see, and there's also an exponent there that we can't see. That's the gist of this lesson, filling in those missing parts even though we can't see them. And that's important because sometimes we need to know what the coefficient exponent is even when it's not there. Let's take a look at this concept in math, or this principle. If you take 1, all right, and you multiply it by a number, you get the same number back, okay? 1 times x is x, 1 times 0 is 0, 1 times y is y, 1 times x to the 700 is x to the 700, because you just have one of that thing. What does that mean? That means that every time you have a variable and it doesn't have a coefficient, you can just put a 1 in front of it, because 1 times anything is anything. Now, 19 is a constant number. We can't put a 1 in front of that because it'd be 119. But when you put 1 in front of a variable, it implies that it's 1 times that variable. So whenever you don't have a number in front of a variable, it's implied that there's a 1 there, because 1 times anything is itself. This includes multiple variables. If I just put the blue 1 in front of that, it's still the same as y to the 7th z to the 4th. It's the same as 1 times y to the 7th z to the 4th. So the missing coefficient, when it's not there, is a 1. Let's take a look at another principle. I want to talk about exponents. When you square something, you multiply it by itself. So 3 squared is 3 times 3. When you cube something, you multiply it by itself 3 times. But anything to the first, you just keep it. You don't multiply it by anything. That's true for 2 to the first, 2. 3 to the first is 3. X to the first is x. So what are we getting at here? Anything to the first power is itself. So when you have a variable or a number or whatever, and there is no exponent, okay, you can put a 1 there, because anything to the first is itself. So for example, from the first page, if we just have x, we could put a 1 in the exponent, and there's the same thing. So when you have a missing exponent, it's also 1, just like coefficient. So for example, 2x, if we want to fill in the missing exponent, we put a 1. 2/3 x, y, z, none of these have exponents, so we can put 1 as all the exponents for x, y, and z. X, this one doesn't have a coefficient or an exponent, so we can put a 1 in front of the coefficient like we talked about, because 1 times anything is itself. And we can put a 1 as the exponent, because anything to the first is itself. All right, let's talk about why anything to the 0 power is, well, let's actually just go ahead and discover what anything to the 0 power is. I like to explain to students why this works the way it does. So going back to exponents, let's talk about 3. All right, let's just start at 3 cubed. Okay, we all agree that 3 cubed is 3 times 3 times 3, which is 27. 3 squared, you're multiplying 1 less 3, only 2 3s. Now notice what happens. The answer that you get, if you're moving to the left, you're dividing by 3. In other words, 3 cubed divided by 3 gives you 3 squared. 27 divided by 3 gives you 9. If I wanted to move 1 more to the left, I'd have 3 to the first. I would take 3 squared and divide by 3 to give me 3 to the first. What about 3 to the 0? Well, basically, if you notice, if you move to the right, you're multiplying each answer by 3. Moving to the left, we're dividing by 3. So it only makes sense that 3 to the 0 would be just 3 to the first divided by 3. Now, what is 3 divided by 3? It's just 1. But what is any number divided by itself? It's 1, right? So what does that mean? Any number to the 0 power is just 1. Okay, this also works for 2. All right, we can talk about that all day long, but when you move to the right, you multiply by 2. When you move to the left, you divide by 2, so therefore 2 to the first divided by 2 gives you 2 to the 0. In other words, 1. It's just 2 divided by 2. So any number divided by itself is 1, and therefore any number to the 0 power is 1. Let's see. Yeah, let's take a look and just generalize this for x. Okay, x cubed is x times x times x. X squared is dividing that by x, x times x. Divide that by x, and you get x. Divide that by x, and you get x over x, which is just 1. which means x to the 0 is just x to the first divided by x, which is 1. So anything to the 0 power you can see is just taking that number and dividing by itself. Very simple concept. And so why are we talking about that? Well, we're talking about that because sometimes this comes into play when you have, and these are just more examples of to the 0 power, but we've just proven that x to the 0 is 1. And so what I want you to see is, let's just say that we had the number 3 by itself, okay? And you wanted to say, hey, what's the variable there? Well, even though there's not a variable there, since x to the 0 is 1, we can actually put an x to the 0 there, and that's still going to be equal to 3. Why? Because x to the 0 is 1, and 3x to the 0 is 3 times 1. Okay, I know this is a little abstract for you. Sometimes this is helpful in math when we say we're doing polynomial division or other lessons. It's useful to fill in that missing variable. So if you have a missing variable, you can always put x or y or z or anything to the 0 power, and that will actually be useful sometimes. Even though most of the time we're going to just be filling in the missing exponents and missing coefficients. For example, though, 7, we could put a 7x to the 0. If we just had 0, we could write 0x to the 0, and that'd be the same as 0, because remember, that's just 1. And then 1/3, we could write 1/3 x to the 0. You don't have to use x. Okay, like I said before, for example, this one you could also write 0y to the 0, or whatever variable you want to use. It's still going to just be equal to that number that you started with, in this case 0. All right, let's fill in the missing parts of this monomial. Okay, so if you notice, this y has an exponent, but the x does not, right? And doesn't have a coefficient either. So we're going to go ahead and do that real quick. What do you guys think the missing coefficient is? In fact, I think I'm just going to put the answers down here. Or no, we'll do it on the next page. Okay, so first of all, coefficient. Actually, let's just go ahead and write the answer, and then we'll talk about it on this page. Okay, so we got xy to the 12th. I'm just going to rewrite the problem here. We already talked about if there's a missing coefficient, it's 1. So for the coefficient, I'm just going to put 1, right? And then for the missing exponent, we talked about that too. If there's a missing exponent, it's also 1. So this is ultimately going to become 1x to the first, y to the 12th. We don't have to fill in this exponent because it's already there. That's pretty much it, guys. All right, we already talked about missing variables, missing exponents, missing coefficients. That's it. That's as complicated as it's going to get, which, as you can see, it's very simple. If you have any other questions about filling in missing parts of a monomial, let me know.